When trying to figure out this limit, the first approach is to, well, maybe if you just take the number -3 and put it in place of all of the x's, maybe it will just equal a number. If it does, since these are continuous, that would be the value of the limit. So this isn't like a bad starting point where you could say, well, maybe I can just put the number -3 in place of x. So that would be -3 squared plus 7 times -3 plus 12, all divided by, okay, then it would be -15 minus 2 times -3, then plus -3 squared. So, like maybe this will work. Maybe I can just take the number -3, put it in place of all the x's, and if it equals a number, great, that'll be the value of the limit. Unfortunately, when I do this, the numerator simplifies to 0, and the denominator simplifies to 0 as well. And 0 divided by 0 is not defined. In fact, it's something that's called an indeterminate form. So unfortunately, it's like if you try this in a calculator, it's going to give you an error message. You can't divide by 0, and 0 over 0 does not cancel to 1. So this is an indeterminate form. But the good news is, if this happens where you have 0 over 0, you can use something called L'Hopital's rule. So L'Hopital's rule says, if you are figuring out the limit as you approach some value of a fraction, which I'll write as f of x over g of x, if it turns out that you get 0 over 0, instead of taking this limit, what you can do is figure out the limit as x approaches the same number, but look at the derivative of the numerator and the derivative of the denominator. So figure out this limit instead. If this limit exists, it's equal to the one that you start with. But the only way you can use this method is if you get 0 over 0. Technically, you can also use this if you get an infinity over infinity, and these will be the two cases that appear within the homework. Okay, so unfortunately, this did not work. So this isn't true, but since the numerator is equal to 0 and the denominator is equal to 0 at -3, what I'm going to do as my next approach is I'm going to figure out the limit as x approaches -3, but this time I'm going to take the derivative of just the numerator and put it here, and then I'm going to take the derivative of just the denominator and put it here. So I'm not using the quotient rule even though we have a fraction. All I'm doing is differentiating the top and the bottom separately. So the thing that will go here is the derivative of the top. So let's see, the derivative of x squared is 2x. Then we'll add on the derivative of 7x, which is plus 7. And the derivative of 12 is 0, so I'm not going to write it. Now for the denominator, okay, the derivative of -15 is 0. I won't write it. Minus the derivative of 2x, we'll get -2. And then we'll add on the derivative of x squared, which is, again, 2x. So if this limit exists, it'll be equal to the limit we started with. So unfortunately, this method didn't work, but I'm going to figure out this limit instead. And I think we can actually put -3 in place of both of these x's, and I think this will equal a value. So let's try that. So at this point, I'm simply going to take the -3 and put it in place of the x's. The idea is, if you can take this number and plug it in and you get an acceptable value, that will be the value of the limit. So let's see, the numerator is going to be -6 plus 7, that's +1, divided by, and in the denominator, we get -6 minus 2 more is -8, which I'll just write this as -1/8. So this limit did exist. This limit here is equal to -1/8 because I could simply put the value in place of both of the x's. And since it does exist, it actually equals the very limit that we started with. This is how you can use L'Hopital's rule to figure out a limit, but you can only use it if you get this thing that's called an indeterminate form.